Hello. Tak češtině to nezvládnu, co doufám. So I guess I will continue in English. Debugging. Who likes it? That's about right. Now the question, the biggest question is how do you debug on using the tool which we need to force quit during the presentation? Just for the good feel of it, I mean, you all work with Xcode, right? So, do you have the latest version of Xcode? Yeah. Do you feel my pain? What is this? It's, if you look at upper info window, it's a successful build, it was running. It's reporting that it's basically not declared. I mean, this tool is full of bugs. So, there is one reason why we are here, and I want to play a short video of the reason. I was smart to preload it.
Now we want to address turnaround, because we got fast turnaround. The turnaround loop, of course, is where most developers spend most of their time. They've got to stop their app, they've got to debug it, they've got to recompile it, relink it, and start it up again, right? This is the classic turnaround loop. But we got some cool new technologies. First one built in Xcode, zero link. We've removed the need to link. We only link objects you need to launch. And so it takes linking completely out of the equation. Boom, gone. Link time, over. Zero. Zero link.
But he did it, so we are here. Alright. So, debugging. This is our tool, and what I want to really talk about is not the tools, because the tools we all know. I mean, Xcode, instruments, I don't know if some of you use Shark for debugging in general, maybe not for iOS. The tools, GDB, GDB, that's all there. That's all the information about the tools is there. It's just go and fetch it. I mean, it's part of the platform and part of what we just need to do. We need to learn how to use them. What I really want to talk about is what are the bugs really? Why they are there? Why we don't like debugging? Why some people are more easy with it than the others. And of course I have examples of the code. Of course at the end I will go, if I will manage time-wise, I will go to the custom tools and show you, maybe not a solution, because there is no really solution, but treat it as a sort of proposal of different approach of something you can do. Maybe it's not a mainstream, but if you bend it to yourself, basically, it can really help. So, nature of bugs. What are the bugs? What are they? Well, retraction of human error. That's as simple as that. There is no problem with the platform, there is no problem with the computer, we are the problem. Maybe because we did not focus, because we have 5 projects at once in the head, right? And the deadline is in a week. Maybe we had too much beer yesterday, that's usually what happens when, regressions happens. And etc., etc. So it's very, very human nature of what the bugs are, and different type of programmers creates different types of bugs, and we all hate them. Now, the bugs are also the measurement of the solution complexity. If you are writing one view, one-page application, if it's, I don't know, calculator, you probably won't have that much problem with debugging it because it's pure mathematics and there is not much into it. But if you deal with something like from the last lecture or from 2 lectures before, where you need to deal with security, where you need to deal with extremely wild environment out there. If you need to give the application to the users, to their hands, and the application is flexible enough to connect to many data sources, to run on different threads, to let the user actually decide about the application flow. It's not you, but it's the user who decides what sequence of function calls are there. Then the bugs and the quality of bugs and the amount of them are pure measurement of the solution complexity. And if the solution is very dynamic, very complex, you have a chance only with the tools which you created yourself. Only with the debugging approach which can really follow application. Not the other way around. The application will not care about NSLog being there or not. Application will do what it does, it will misbehave. There is no solution. There is no bug-free solutions. No, absolutely not. There is, if there are, that does not mean the bug is not there. It just means that it didn't happen yet. So that's what they are, why they are. Well, most of them are actually reminders of unconsidered scenarios. Maybe you didn't think about that user will go to the metro with the application which is constantly connected to the network and so on and so on. So that's the negative part. The good part of it, that there is something we can learn from bugs, and they give us a chance to look at things which we did not look at before. They give us a chance to improve the solution, to improve the application. And well, what's in the parentheses, I think it's the most relevant to us. Every time we get a new framework, some open source stuff, MClean, Network Kit, whatever you're using, looking at how it works and what it does is not really the first thing we do. What we really want to do is to use it because it saves time, because someone else put the time to develop it. When the bug in this framework will never happen, very often we never go there. So we will never actually understand how this framework works. So this is what the bugs gives us, the possibility to come back, to look at it, and to learn, actually. So get better and learn frameworks. That's what we can do, what we can get from debugging. The nature of bugs and types of bugs are, this is just, I will run through it really quickly. I really needed to organize it a little bit for the sample, which I have to make sense, I guess. So code errors, that's what happens. Application does not even compile, debugger shows the red stuff. Scope of the function file import, it's very small and it's easy to fix because it's right there. It didn't even go out to the wild. It's right on your computer. You can fix it. So when the app crashes and when the crash is consistent, that's what they call as app crashes. It compiles and runs. Crash always happens at the same place. So it is actually easy to reproduce if you have enough information, and how you collect the information, that's what my sample is about. And the crash log is always there. That means you have done something really not, really forbidden in the runtime or on the platform. Probably the worst type of bugs are, well, not the worst, second worst, are logical errors. When it's the situation where the app is running, most of the times, absolutely without a problem. Crashes are random, or they appear random. They are not random, but they appear random because when the solution is dynamic enough, you will find yourself many different ways to end up in the same point in your application. So they appear random. Different people telling you that they have done different things in the sequence and they got the same result. Or actually, they don't know what the result is, they just know that it crashed. Crashes are hard or almost impossible to reproduce because they're sort of randomized and no one can really explain what was done right before the crash happened. So crash lock is useless or close to useless, points to native framework or simply the crash lock is not there. It happens as well. The app just quits and you will never know why. The app does not crash at all. It's just not doing what it's supposed to because of logical error in the app, but not big enough to raise uncounted exception. Now the regressions are something I personally hate the most. It's the situation when you change something in the app and yes, it was working yesterday. Really, it was working yesterday, no kidding, and today it's simply not there. The app misbehaved and it's doing some weird things. However, there is too much code to just reverse back because you could just pull the previous Git commit and start from scratch, but what if you changed 15 files? And it can be any of the above types. The regressions, once we introduce regression for one or the other reason, we never know what kind of type it's going to be. So we have basically two types of approaches, and it's not like we are one or the other. We always have both. We always have both. And the groups I create are code masters and developers. And what I mean by that, and I need it because it will make sense in a second, you can just wait through. The code masters are the people who are really one family of languages. They know everything about the platform. They can write the code with closed eyes. They can be disconnected from anything and create application in the forest. Just because they know frameworks by heart, they know runtime, they know debuggers, tools, everything. They dig so deep in one type of platform or environment that they don't really have time to look around. Now, the other type, of course, what I call developers, are the cross-platform people. They touch, I don't know, 10, 15 different languages. They try, well, everything, close to everything around. They can create impossible links between the frameworks just because they have enough overview of what's out there and they can see the connections. Now, they do as much as needed, the digging in the platform, only as much as needed and not even one inch further of to bring application to life and to create it, but they are hardly able to answer the question how this framework works if you really ask them, if you push them to details, because they don't have time for it. And we are always both, always both. It's not like some of us are code masters and the others developers. We have both sides, and depends which side is which side is stronger. Basically, we have different approach to debugging, and we will like or dislike different things. And now there is the 80, it was something what they called 80-20 ratio, and it's this 20-80 division is out there. It's in economics, it's in our private lives, it's everywhere. So I'm using it. It's don't stick to the numbers. The numbers are wrong. 20% of the times you're probably right when the bug happens. 20% of the time you know where it happened, you know why it happened. Well, 80% of the time the reality was exactly opposite what you think it is. And this is true for all of us. So following this rule, well, no, it's not gonna take just 10 minutes because the bug might be too large to be. Following this rule, no, it's not the server-side issue. It is on the client. Following this rule, it is not in the place you've been looking at for the last few hours, so this is just ghost time. It's something that you need to get over and start all over again. And unfortunately, when someone reports back to you, then yes, I know how to use an iPhone. Because we have our attitudes and we have our bad days. So how much we hate things, code errors. Start with code masters. Regressions, don't care. It's not in my part of code, it's not in the files I wrote, it's just go away. Logical errors, yeah, I will have a look at it, but where's the guy who created the system? Where's the architect anyway? Like, it's his problem, right? It's logical error. The app crashes, that's interesting because that might be in a function which I, as a code master, might improve actually. So this is something I can do. And the code errors, well, I'm just gonna suicide because this is right slap in the face. So I'm a code master and I can't write the code which compiles. Right? Now the developer part of us, it's the exactly reverse. The code errors, I don't care. I'm new to the platform. I have 1 month to learn the language, learn the platform, and deliver the application. You know, it's a code. I will fix it. I don't care. So app crashes. Yeah, I will have a look. But where is the coder? Where is the code master from the platform? He can fix it 10 times faster, right? Now the logical errors. That's interesting because that's the connections between things, and that's exactly what I do. That's exactly what I want to spend my time on. And regressions. Well, no, I quit. I created something, it worked yesterday, they broke it, I don't want to deal with it anymore. So that's our attitudes, and now that's our approaches to bugs, and now a little bit of debugging is, the big part of debugging for me personally is about taking a big step back. Take a distance to what you just have done. You've been working on the solution for 4 months, yes, but this last 2 days of debugging is actually what makes it usable. It's actually what makes you deliver, and that's almost your paycheck, actually. Because you might spend have a wonderful time creating code, and if it does not do what the client ordered, then it's hard to explain. So when the code error happens, I mean, the compiler debugger will point it out to you. So check typos, check includes, check framework availability. Maybe you did not include something. Clean the build folder. And clean the build folder is the button combination, I'm sure you all know. Remove all the derived data, everything from Xcode, what Xcode just built it, because it has built it wrong, because Xcode itself is full of bugs. So, sorry. When app crashes, basically plug it in and reproduce the crash, because when it crashes, well, the bug is running, you will find it immediately, you don't need to dig through the crash logs. But if you are digging through the crash logs because there are clients or testers sending it to you, look at only at the threads where actually the crash happened, because it's not necessarily always there, but it will point you quickly to the place where it's supposed to be. And ask around, because when the crash happens, the other people might just Google it. They might already been dealing with this problem, with this framework, and so on. Logical errors, that's something I like. That's something you need to take a special care of, because the bugs are not consistent, because there is no clear way to reproduce them, recreate and trans the normal flow of the application. And I call it, and it will appear later, I call it 5 function names rule. If there is a logic flow behind the button, and you press the button, and you can't remember the names of the 5 functions which follows, you don't know the logic of the application. That's how I see it, and that's, you don't have to take it like that, but that's my personal approach. So what I like to do very often is to just trace just the names of the functions. Because when it's normal flow, I don't need to take care of the variables and what the function actually does, and just tracing the names to remember the workflow. So when it crashes in a certain function, I might go much quicker to the idea actually what was the sequence and why it happened. And then of course try to recreate while tracing. Because when the bug is, when you are not tracing and you recreate the bug and you have the crash report might be really not helpful at all. And by tracing, I mean not waiting for a bug, I mean tracing the logic flow of the application. Look at the names of the functions in the sequence, look at all the variables on the way. What I do, and what I will show you in the code, it became a habit for me. I'm not using it always, of course, but it's a habit. I'm putting the log right in the beginning and right at the end of the function. I trace all the inputs and actually the output, the return value, or whatever the application is doing. So when it crashes, I have at least the last couple of calls, and I can possibly maybe recreate it. With the logical errors which are hard to reproduce, you need to push the app to really limits. Don't be gentle. No user will be gentle with your app. They will just do whatever they want to do. They will just, they don't care. They are not gentle, and you shouldn't be gentle. So push the apps, do absolutely stupid, do absolutely impossible. Press 5 buttons at the same time. It's just try to recreate it at any cost, basically. Then use live tracking tools. What I mean by that is create tracking tool that is at least as flexible as the solution is, which can actually follow the application, which can follow the logic, which can be right there when the bug happens. And remember that every single assumption will set you up. That's a golden rule for me. Every time I make an assumption, it sets me back. It's like 2 hours lost or 1 hour lost, and I have to start from the scratch again. And custom tools, it's something I want to go quickly to. Now the regressions. There is the way I find it useful and find it easier is I always pull the last working version from Git or SVN or whatever you guys are using. I'm tracing the last working version, I'm tracing the not working version, and I'm looking for differences. That's all what I do. Looking for differences in the workflow, because once I find the difference which I find might be not the reason the application crashes immediately, but it might be the reason why it crashes when it's coming back from the background, and so on and so on. It's like the 2 pictures and 10 differences between the pictures for kids. Once you find all the differences, you will find the bug. So this is the only way to deal with regressions. For me, of course, you might have something better. And every time you take a shortcut, it will generate 1 more hour. It's just the way it is. It's impossible to take a shortcut in regressions, because regression happened exactly because you took a shortcut. in the first place. So, custom tools. By custom tools, I mean custom tracing object or function, or whatever we want to call it, or the system. And the way I'm trying to create one, the way I'm trying to use those, the ones which I create, and I change them a lot from one application to the other. I don't use the same for the application which stays on the client non-stop and which goes a second button goes outside and fetches data from web services, because they're not they would be not working accordingly to the solution. So what I'm trying to do is remember the 5 functions rule and do tracing on the daily basis. Do trace at least once per day, see what's the healthy state of the application. Then be there with your tool when the crash happens. That means until the app is in the App Store, what I do is I have the tracing tools non-stop on. Non-stop. I don't care if it's, the console becomes unusable or the log file is a couple of megabytes. I need to know what's going on there. Now the get trace data in app, right from the code. Do not hope for good testers or clever users. It's not going to happen. No, the normal people, the clients or whoever, they might be, in US, they might be in France, there might be a distance, you might have no contact. They might just send you some stuff over the email, but they will not write you the step-by-step what they have done with the application, because 20 seconds after they do it, they don't remember. That's how we use apps. That's how I use apps. Now, follow the app. Basically, what I mean by that is the tracing tools should be as flexible as you wish it to be. There is no limit. If I want to override some buttons, I override some buttons just to do what I want to do. Because I need the information about what actually is happening in the app, and design your own tools, because only then they will reflect your needs. You know what's your approach, you know what's your coding style, and you know what kind of information you need. So simply go there. Now, how to get better at debugging? Here's the crazy idea. We learn by doing, so create bugs. Simply create bugs, and there is no bug-free thing out there. The bugs are not the reasons why someone will call us bad developers. No, the bugs are the reasons why we are getting better. So create them. That's not good. So what I want to do now is I want to go through the code and show you more or less what I mean by custom tool. 1 second. There we go. So what it is? It's a something I put together in a matter of hours. You can take it as it is, use it, but I would be even more happy if you take it as it is and modify it so I can't even recognize it, because that's the whole point. The point is to start to create your own tools, your own tracing scenarios, your own approach, which I bet you do, but that's something sometimes we forget, myself, because it's not the most, I don't know, exciting thing to do, maybe. What this does is basically it's a little game. I create bugs and I kill them. So it's, you see, debugging is simple. I just click on them and they disappear. And there is no points, no nothing. And when the circle above happens, you can't click them and so on. So that's the whole thing. But what's interesting is what's going on here. It logs every single function code, every single one, and that's amount of information here is very dynamic. So basically what I can do with this tool is to change this information live as it runs from one function call to the other, and it will follow. Unfortunately, I can't do it on the simulator the way I've done it because when the iPhone first came out, I started to think immediately, like, wouldn't it be so cool if there would be like debug button on this device, which I can just press and it will show me exactly what I need to see. And it appears so, no one pointed it out, but it appears so there too. And it's a volume up, volume down. So the way I did it with this application here is, one second. Okay, so here's the application. It is running normally. And now what I do is I press the volume 1 button. Information appears on the top what kind of logging is in. And by pressing the volume up and down, I'm basically changing the amount of information which I'm receiving. I have 15 levels there. About the level 0 is, of course, the log is off and it's not logging anything. The number 1 is just the function name, and number 15 you can imagine. There are different scenarios, and I can even see, if I would see something really weird going on with this app, then I can even do this. Yep. Yep, there we go. It's a built-in debugging console right there, and it updates live as it's tracing. So that's it. That's what I do. And by pressing the volume down button, it will stop you there. Sorry. It will change the amount of information which I'm typing. Now what I have here as well is the email button. And it takes the content of entire log file and sends it to actually start bugging me at impulselab.com. Of course, if I don't need it anymore, it's enough if I just double tap and it goes away. So now, how it's done, there is one object. It's a single tone, it takes care of everything. Now, what I have here, okay, first things first, originally I took it from wackylabs.com. I will put it on my website, you can download it later. The guy created the main logging function, which I extended to, because I wanted it to extend. So what I have here is is the hook to. And it happens right here, is the hook to volume buttons, which I don't override their behavior, they still change the volume for the device, but I get the click. So and by the click, volume down presses the log level, one level down, volume up goes up, of course reaching the 0 and the maximum. I create my console built in the application. So if the console is up, here is the main debug function, and what it does, I will still create some macros because they are much easier to use in the code. So the main macro is dblog. It takes normal stuff as the nslog would do, and whatever extra information I need this object adds itself. In the code, you would use dblog exactly as you do with nslog. No difference. No extra typing. No extra taking care of it. Because we don't have time for it. So it would be nice if this would actually take care of the source file, the line number, the function names, everything else I need. Memory, free memory, and so on. So a little bit run through what I have here is different log levels. So the function, the variables from the function as exactly as it would come from nslog, then function name, source file, line number, memory, free memory on the device which is left. If you have the application which allocates a lot of things, basically every single function, every single logged entry gives me the trace of where and how the memory has been consumed. Then I define a couple of arrays where I can exclude some objects. I basically write it right here in the exclude object. All what I need to do is to write the object name. You can get it from object class description, or just at the end it's a simple string. Just write the string of the object. Every object which is in this exclude object array, if I choose this level of log, they're gonna disappear from entire trace. And it helps because I don't know if you use the mkNetwork-Kit. mkNetwork-Kit is logging, it's able to log tremendous amount of information. If you start to trace all the calls out and all the JSON which you get back, I mean, you're never gonna find the end of it. So what I would do, I would exclude some objects from the framework I trust. Then you can exclude files. Maybe overkill, but here I have the little sample of what I found people do a lot. In open source things, they define two different objects in one file. Maybe I don't need them both, so I have this possibility to exclude not only objects, but also entire file. Exclude functions, function names. I mean, if I have, I don't know, set needs display or layout or whatever, or draw rectangle functions there, and I want to have exactly the same function exclude from my log file so it does not clutter the picture. I want to remove from all the objects, basically add it there to exclude function, and if the function name matches, it will never appear there. Then I have includes, of course. I mean, by the default, it might not log anything, and if I want just exclusive set of things, then I can include objects, sparks, functions, and you can, of course, define the pop-up, which is extremely annoying, because when the log will happen, the simple blue pop-up appears. So this is close to what I would like to have. Now, of course, there is this little drawback, like when you create the function and the function call, you need to put this dblog right there. It becomes very quickly. I think, at least for me, it became very quickly a habit. I don't even consider this as extra time anymore. It's just something I do. And based on the information I get when the crash happens, and I can make it crash really easily here actually, because prepared so it crashes. One more thing which is here, which I set up, is the handler for uncode exception, which will basically log exactly the same information. as you get in the crash log. So when it happens live on the device, you have it in your log file. So when you, as you've seen, when I launch the application and the log file is with some errors, or it's actually not empty, the first thing I see is possibility to send it. Once I send it, or not, for that matter, and now it crashed already. Once I send it, it gets truncated, or not, depends on your choice. So here is my log. It crashed. It crashed right after the class 2 call from function 4 unrecognized selector assigned to an instance, of course, because I didn't implement it. But, and all this information before, what you see. Let's say that would be a scenario I did not create for the presentation, but this is a scenario where I give this application to users and they are just running somewhere. South France, and they're doing something with the application, it crashes. The next time they open application, they're immediately prompt to send this information to me. And this information is not only the crash log, it's entire cycle of the application. Everything what happened on the way, everything. I don't need to ask not even one question what they have been doing with the application because I can see it right there. Not even one question. No one has to explain, no one has to remember, no one has to act stupid or act smart. It's there. I collected it on fly, on the way. It does not slow down the application, basically. I've done some tests, unless you're running video editor or something extremely processor intensive, then maybe, but one log, writing to the log file will not slow down your application. And this is the, while creating the solution. So this is basically to prevent for this to happen when it's live. So that's dblog. That's what I like to do. I like to see basically what's going on. When the crash happens, I don't want people trying to explain and stuff, because first of all, they might be not there to explain, second of all, they might be not willing to explain, or, yeah, and they might be not able to explain because they don't know what kind of code I wrote, they don't know what is happening. And this way, I know. I get it on email, I don't even need to talk to people, I just fix it. So this is my approach to debugging. I don't know if it makes it any more sense to you, if it makes it any easier, but I think and I really believe that we should adjust a little bit the way we debug stuff based on the type of the solution, the type of application, because they are not the same. They're really not the same, and they will not let you to debug them in the same way. We do not design them the same way, they do not behave the same way. It's like you would try to have exactly the same approach to all your kids. It's not going to happen. So that's debugging.